freecoachingtoday.com.
So let's take a look at another example on Newton's law of gravitation. Our Earth this is our Earth, and it has a mass of 5.9721 into 10 to the power 24 kg, and its radius r, I've deliberately made this radius just about outside its surface, and it has a radius of 6.378 into 10 to the power of 6 meter. And let's say a particle is released just above its surface and then released. So compared to the huge surface of R, this distance when it's placed just above its surface is almost negligible. The question is, when I release it using Newton's law of gravitation, what is its acceleration? Let's see. This force F is given by Gmm divided by R square. M is the mass of Earth, small m is the mass of this particle. So the acceleration of this particle is given by F divided by M. It is equal to Gm upon R square. If you put up this value, G is 6.67 into 10 to the power minus 11 multiplied by the mass of the Earth is 5.9721 into 10 to the power 24 divided by R square is 6.67 multiplied by 10 to the power minus 11 its whole square. So we will try its radius is 10 to the power 6, sorry. So let's try to get an approximate value of it. It's this one is 6.378. Sorry about that. So if you try to solve it, we get something like that. 6.67 into 5.972 divided by 6.378 into 6.378 multiplied by 10 to the power of minus 11, 10 to the power of 22, and 6 into 2 is 10 to the power of 12. Now 10 to the power 12 goes up, and 10 to the power 11 becomes 10 to the power minus 23, and 10 to the power 24. So this whole thing becomes 10. So we have 6.67 multiplied by 5.972 multiplied by 10 divided by 6.378 multiplied by 6.378. You can guess that this is close to unity and this is 10, and if you actually calculate it using an Excel sheet or whatever, you will get a value something like 9.79, and the unit turns out to be meter per second square. And this, what we know, is our acceleration due to the gravity, which we also sometimes denote as g. Now that leads us to another question. Let's say we ask the question, find the initial acceleration on the Earth due to the 1 kg particle released just above its surface. So what will be the result? We have F, the force between the Earth and the mass is Gm upon R square. So the acceleration of the Earth Am is F divided by capital M. Then that is given by Gm upon R square, where small m is the mass of the 1 kg particle. Of course, if you double this mass, this acceleration on the Earth will double, but still it will be a very small figure. Let's see how much it's going to be. G is 6.67 into 10 to the power minus 11, mass is 1 kg, and the radius is 6.378 into 10 to the power of 6 whole square. As you can see, this is of the order 6.67 divided by 6.378 squared multiplied by 10 to the power 12 plus 11. So 12 plus 11 is minus 23 meter per second square. Or this is roughly of the order of 10 to the power of minus 24 meter per second square. So Earth does feel an acceleration due to a 1 kg particle when it's released, but this acceleration on the Earth is almost negligible.